Welcome to physics class. Today I am going to discuss next examples. Example 9.3.
See example 9.3. A motor car is moving with velocity of 108 kilometers per hour and it takes 4 seconds to stop after the brakes are applied. So in this line, can you tell what is given? Motor car is moving with this initial velocity. That means u is given 108 kilometers per hour. Time is given 4 seconds. It takes 4 seconds to stop. That means final velocity after 4 seconds becomes 0 meters per second. So we can convert this initial velocity in meters per second by multiplying the factor with pi by 80. Now you can solve it. 2, 5, 4, 9, 6. That means 30 meters per second. Calculate the force exerted by the brakes on the motor car if mass along the passengers is 1000 kg. That means total mass is given 1000 kg. Okay, we have to calculate the force. As we know, force is mass multiplied by acceleration. And here acceleration is change in velocity with respect to time. Now put all the values here. F is equal to mass 1000. Final velocity V 0. U 30. And time is 4 seconds. So now solve it. 1000 multiplied by 30 minus 30, you can put minus sign here, divide by 4. Now calculate. 2 2s are 4, 1 5, 2 5s are 10. That means minus 7500. It means the force is minus 7500 Newton. So this is the retarding force.
Now see example 9.4.
Example number 9.4. A force of 5 Newton gives a mass m1 and acceleration that is 10 meters per second square. That means for mass m1, acceleration is 10 meters per second square and force is 5 newtons. And for mass m2, acceleration is 20 meters per second square. What acceleration would it give if both masses were tied together? It means we have to find out the total acceleration produced by the combination of these two masses. And for these two masses, the force is same, that is 5 newtons. First of all, we have to find out the values of these masses. As we know, force is mass multiplied by acceleration. So here, for mass m1 and acceleration, we have the force 5 newtons. But with the help of this expression, we can find the value of m1. m1 is f divided by a1. f is 5. a is 10. 1 by 2, that means 0.5 kg. For mass m2, similarly as f is equal to m2 a2, then m2 is f divided by a2. f is 5, a2 is 20, that means 1 by 4 kg. 1 by 4 is 0.25 kg. See, if these two masses were connected together, that is M1 plus M2, 0.5 plus 0.25, that is 0.75 kg, we have to find out the acceleration produced. Again, as F is equal to Ma, we have to take the combined mass M1 plus M2 multiplied by acceleration. So here force we know 5 Newton, 0.75 A. Then A will be 5 divided by 0.75, that is 5 multiplied by 100, 75. You can solve. 25 3s are 25, 4s are 20 by 3. It means 6.6 meters per second square.
Example 9.5.
Example 9.5. Velocity time graph of a ball of mass 20 grams moving along a straight line on a long table is given in the figure. This is the velocity time graph for a ball. And mass of the ball is given 20 grams. You can convert it into kg. 20 divided by 1000. That means 0.02 kg. We have to calculate the force table exert on the ball to bring it to the rest. That means after applying the force, the ball will come in rest. That means final velocity becomes 0 meter per second. And from the graph, ball is moving with initial velocity 20 centimeter per second. So here you can convert centimeter into meter, that is 20 divided by 100 meter per second. So you can write U is 0.2 meters per second. And for this velocity, time is given, that is 10 seconds. Now see, we have to calculate the force as F is equal to Ma, mass, acceleration B minus U by T. You have to put all the values here. F is equal to mass is 0.02, final velocity is 0 minus U is 0.2 divided by T. T is 10. Now further solve, we get 0.02 minus multiply by 0.2 divided by 10. So here you can bring these decimal points, 0 here, 2 zeros and 1 zero is here. We get, now here we can write 4 divided by 4 zeros, that is equal to minus 0.1234 Newton. This is the force. Now here we can write 4 divided by 4 zeros, that is equal to minus 0.1234 Newton. This is the force.